Hi guys, my name is JJ Khoza. On this lecture we're talking physics. We're doing physics. I want to show you something interesting in physics. But there's something that you must understand clearly, that if you want to understand physics, make sure that you understand mathematics. Otherwise there is nothing that you can do. Physics is theory. It explains concepts, and when you're supposed to do the calculations, you need to understand mathematics. So on this lecture we're talking about equations of motions. But before that, I first want to remind you of two things. Number one, it is scalar. Number two, it is a vector. So you've got to have a clear understanding of these two concepts, scalar and a vector. So a scalar, it's anything with size, magnitude. It has got magnitude. And a vector has got a magnitude, okay, magnitude, what am I doing? Magnitude, and it has got direction. I hope you still remember that. So you must be very careful of this, because it has got very important implications. Right. So now, when we're talking about motions, of course, we're talking about objects that are moving. So the first thing, you will want to know how fast an object is moving. Okay? And there are two equations that you can use, or there are two concepts that you can use to measure how fast an object moves. So the first one, so when you talk about how fast, right, you're asking a question. We've got two things again. One is a speed, right? A speed. When we're talking about speed, we are talking about distance covered per unit time, right? This is distance covered per unit time. Unit time, okay? This is clear. And a distance is the point and then number two, we're talking about a velocity. Velocity. You guys, you must on your own find out what is a distance. On your own. I nearly told you. So on velocity, we're also talking about how fast an object is moving. So here we're talking about displacement. Displacement covered per unit time. Covered per unit time. Okay? So now we've got two things. We've got a scalar and a vector. We've got a speed and a velocity. Now, you must understand the following. How are we going to use the scalar and the vector? A speed is a scalar. A velocity is a vector. A speed is just how fast you're moving, meters per second. But on the velocity, is also measured with same SI units, meters per second, but the difference is this direction. So you can say that you are moving at 10 meters per second north. So that's the difference. So you must remember that. Okay? A speed is a scalar. velocity is a vector. This should be clear. Okay, right. So now, how do we calculate a speed? We're doing calculations now, right? A speed is equal to distance covered, of course, over time taken. Time taken. And we represent it as speed s is equals to change in d over change in time. What is change in d? It means d final minus d initial over t final minus t initial. Final is the destination, initial is the starting point, right? So now you understand, okay? And then we also come to velocity. Velocity, we use displacement. Displacement. You must remember to find out what a displacement is and actually be able to differentiate it from speed. So it's displacement over time taken, and we say v is equals to the displacement. We normally write it as change in x, okay? This is just a notation we're using in physics, over change in t, right? This is it. So now you know delta is change. It means x final, the final destination of x, minus x initial, the starting point. Similarly to time at the final destination minus time at a starting point or initial point. This is what we're dealing with. I think it's simple, right? Now I want us to move into something very important that normally gives you guys a tough time, and there's no need for you to stress. It's doable. I want to discuss the derivation of equation of motion, right? So to derive equation of motion, you will excuse my handwriting. Here we're going to discuss three equations. The first one, we will be talking about acceleration, right? Acceleration. Acceleration. I will define acceleration, right? So acceleration, it is change in velocity over change in time. So what does that mean? That is just a mathematical notation. It means that when an object is moving at a particular velocity, there is going to be fluctuations in velocities, or it's going to be constant, and it will be measured in time, right? So now, how do we actually express acceleration? Simple. We just imagine it as the change in velocity over change in time. So I'm just going to do this notation, of which you are now familiar with. It's important to be familiar with notation. This is delta. It means change. You've seen it before, right? So this is how we do it, right? Now, We are going to work with this equation of motion. This first one. We are going to do magic out of it. Number 2. Right. Okay. On number 2, we are going to have average velocity. So when we are talking about average velocity, you know average, when we do statistics in mathematics, you take things and you calculate the average. So essentially it means that we are going to divide by 2. So we're going to talk about average velocity here. Average velocity. At 3, we are going to talk about acceleration again. So we are going to be back to acceleration. Right. So these are the 3 equations that we will be talking about. Acceleration, we are going to use it differently in number 1 and in number 3. So let us do a demonstration now. Okay, so let us take equation number 1. Acceleration is equal to change in v over change in t. We now know that this delta means final minus initial. Therefore, we can say Vf minus Vi over Tf minus Ti. Sometimes they make this thing very simple. Vf becomes a V and initial becomes a U. Right. Becomes a U minus U over Tf minus Ti. But for now, let us use Vf and Vi. Alright. So now, what do we have here? It means that A, acceleration, is equals to Vf minus Vi over T, change in T, over change in T. So Tf minus Ti. So from here, we are going to multiply time. We're just doing a cross multiplication. We want to make a velocities subject of the formula, right? So simple algebra, A into change in T. Remember, this is change in T, is equals to Vf minus Vi, right? And we transpose Vi. We have A change in T plus Vi equals to Vf. Voila. We have our first equation of motion. Vi plus acceleration, change in time. This is how you derive it. Simple. Simple. Look. So here you had your acceleration here. Acceleration equation. And your change in V is Vf minus Vi over change in T. So you just do cross multiplication. You multiply change in T with A so that you get your A change in T here. And then you transpose your Vi. You have final velocity equals to initial velocity plus acceleration times change in time. That's it. Right. So now let us move to the second equation. On the second equation, we are using average, right? So we are talking about average velocity, okay? On average velocity, we are talking about Vf minus Vi over 2. Simple. Nothing more, nothing less. So we know that velocity is actually equals to change in displacement, is displacement over time, right? Now, this is the section that we're going to use, this. So we have Vf minus Vi. Vf minus Vi over 2 all multiplied by change in t equals to change in x. And therefore, finally, we have our change in x, the displacement. We have our displacement. Change in x is displacement. We have our displacement equals to, now we know, change in t into Vf minus Vi over 2. Simple. What did we do here? Average velocity is final velocity, subtract initial velocity, divide by 2. We know from definition of velocity that velocity V is equals to change in displacement over change in time here. And therefore, we also know that average velocity is Vf minus Vi over 2. So we equate this set of Vf, Vi over 2 and displacement over time. And we made displacement, change in displacement, subject of the formula, change in x. That's it. Nothing more, nothing less. Finally, we are working on the acceleration equation again. We know that we have A is equals to Vf minus Vi over change in t. Okay? So, we already know that we can make t subject, time subject of the equation or of the formula. We end up with Vf minus Vi all over A. Simple. Okay, so now we want to substitute this. On the previous equation, we made, what did we do? Let's check. We had this, okay? And now we want to substitute change in t in equation 2 from equation 2 above. So now we substitute change in t in 2 above, right? This is equation number 2, this one. We're supposed to substitute change in t in this equation. So what's going to happen? We are going to have change in x is equals to Vf minus Vi over 2. Okay, remember we had multiplied this by change in t. So now our change in t is also this section here, instead of multiplying by change in t. Look, here is the change in t, and this is the component of Vf minus Vi over 2, the average velocity. Here is the change in t. Now, instead of putting change in t here, let me just put it deliberately so you can see. So change in x, we have Vf minus Vi over 2 multiplied by, right? We do have our change in t here. It is Vf minus Vi over a. Okay, algebra again. Let's do multiplication. Vf times Vf, we get Vf square. Subtract Vi times Vi, we get, what do we get? Vi square, right? Over 2a. This is what we have when we do our multiplication. And we end up with 2a change in x equals to Vf minus Vi. The end result is Vf final velocity squared is equal to Vi squared plus 2a change in x. Okay, change in x. This is your third equation. I hope this is clear. Thank you.